Okay, let's dive into this. Welcome to today's Explainer, where we're taking a highly technical and honestly often completely misunderstood concept and making it totally unforgettable. If you've spent any time at all around modern web development, microservices, or building APIs, you have undoubtedly bumped into three little letters: JWT. Today, we're demystifying JSON Web Tokens. We're going to strip away all the complex jargon and look at exactly how they work through some of the absolute best visual analogies out there.
So let's just start with a super simple question. Why is JWT everywhere right now? Well, to really grasp this, we need to think about a highly frustrating, totally relatable experience. Imagine you go to a huge multiplex movie theater on opening night. You want to see the movie, maybe grab some popcorn, and hit the VIP lounge. But there's a huge catch.
If this theater operated without JWT, it would be a total nightmare. Imagine the traditional setup. Every single time you walk through a door, whether it's to the lobby, the concession stand, or your specific screen, a security guard literally stops you. They ask for your name, they pull out a radio to check with a central office database, they verify your booking, and they confirm your payment, over and over again at every single door. It's incredibly slow, and that poor security guard in the central office is just completely overwhelmed. Now contrast that with the absolute paradigm shift of using JWT. At the main entrance, you show your ID just once. The theater verifies you one time, and they hand you a VIP movie ticket. Now, wherever you go inside the building, screen 1, the food court, the VIP lounge, you simply flash the ticket. Nobody asks for your name again. They just look at the ticket because the ticket itself contains all the necessary information.
And that brings us to Section 1. What is JWT, the JSON Web Token? Simply put, it is the exact digital equivalent of that VIP movie ticket.
To really lock this in, here is the ultimate three-step memory trick. This single sentence perfectly explains how stateless authentication works on the web. Step 1, you log in once. That's you showing your ID at the front door. Step 2, you get the token. The server hands you your digital VIP ticket. Step 3, you use that token everywhere. You just attach that token to every subsequent request you make, and the server automatically knows exactly who you are and what you're allowed to do.
Now, if you've ever actually looked at a JSON Web Token in the wild, it doesn't really look like a VIP ticket, does it? It looks like a terrifying, compact string of random gibberish. But we are going to break that scary-looking string down into three simple parts in Section 2, the JWT burger, Anatomy of a Token.
Try to visually stack this in your mind. A JSON Web Token is literally just three distinct parts of data, and they're simply separated by little dots. Think of it exactly like a burger. You've got your top bun, which is the header, you have your patty, the meat of the token, which is the payload, and you have the bottom bun, holding the whole shebang together, which is the signature. Let's take a look at each layer from top to bottom.
First up, the header. Now, what's really interesting about this slide is that the header doesn't actually tell us who the user is at all. The top bun just acts as the recipe used to cook the burger. It simply defines the type of token, which is JWT, and the algorithm used to sign it, like HMAC SHA-256 or RSA. So really, it's just metadata.
Next, we get to the patty, the payload. This is the actual, tangible information written on your movie ticket. This is where the really useful data lives. It contains crucial details like the user ID, their username, their role, so maybe they're an admin or just a standard user, and their specific permissions.
But here's where we really need to pause, because this leads to the most common and, frankly, the most dangerous misconception about JSON Web Tokens. It leads us to a critical plot twist and a very important question. Is the payload secret? Take a second and answer that in your head. If someone intercepts this token, are your user ID and your role hidden from them?
The answer is absolutely no. It is not encrypted at all. The header and the payload are just base 64 encoded. All that means is they're merely translated into a different character set so they can be sent safely over the internet in a URL. Anyone, and I mean literally anyone with a web browser, can decode the header and the payload in a fraction of a second and read every single thing inside it.
Because of this, you absolutely must follow this golden rule. Never store sensitive data inside a JWT payload. No passwords, no credit card numbers, no one-time passwords, no secret API keys. If you put it in the payload, the whole world can read it.
Which naturally brings up a massive question, right? If anyone can read the token and anyone can decode it, what on earth is stopping a malicious user from just decoding the token, changing their role from standard user to super admin, re-encoding it, and sending it back to the server? Well, that brings us to the bottom bun, the signature. This right here is the absolute most important part of the token. The signature is what protects the JWT from being modified by an attacker.
Let's use an easy memory trick here to reinforce this. So which part of the token is actually secret? The header? No, anyone can read it. The payload? Nope, anyone can read that too. What about the signature itself? Nope, that's attached right there at the very end of the string for everyone to see. The only thing that is truly a secret is the secret key. This is a private key that lives exclusively on your server. When the server first creates the token, it takes the header, it takes the payload, and it runs them both through a mathematical algorithm using that secret key to create the signature. So, the ultimate interview tip and crucial takeaway is this quote right here. JWT provides integrity, not confidentiality. If an attacker changes even a single tiny letter in the payload, like changing standard user to admin, the payload no longer matches the signature mathematically. When the server receives that tampered token, it runs the math again using its secret key, sees that the signature doesn't match the new payload, and instantly rejects it. It's incredibly secure, not because it hides data, but because it absolutely guarantees the data has not been tampered with.
Let's move along to Section 3, Stateless Authentication, and why JWT is fast. Let's see how this structure allows the server to trust the token instantly without digging through a database. Let's break down the technical differences by comparing a stateless JWT to a traditional stateful session. In a stateful session, the server has to keep a massive ledger in its database of every single logged-in user. Every time you click a button, the server has to do a database lookup to check if your session ID is valid. That's our overwhelmed movie theater security guard from earlier. But JWT is stateless. There is zero database lookup required to verify the user. The server just checks the math on the signature. And because the server doesn't have to remember users, it is incredibly, infinitely scalable. This is exactly why it's become the standard for modern microservices and distributed apps. Now, just like a real VIP movie ticket, a JWT doesn't last forever. It expires. The payload contains standard fields which are known as claims. You're going to find common claims like sub for the user ID, IAT for when the token was issued at, and crucially, EXP for expiration. Once that exact expiration time passes, the server will mathematically reject the token even if the signature is perfectly valid. This is vital because it limits the window of opportunity if someone happens to actually steal your token.
Okay, we have covered a lot of ground, from movie theaters to burgers to cryptographic signatures. Let's lock this all together with one final brilliant analogy in Section 4, the final anchor, the boarding pass. And this brilliantly illustrates the entire concept. Imagine an everyday airport boarding pass. The header? That's the airline's information at the top. It just tells you who issued it. The payload is your actual passenger detail, your name, your flight, your seat number. It's printed right there in plain text. It's not encrypted. Anyone looking over your shoulder can read it. But the signature is that physical airport security stamp they put on it. And the secret key? That is a security officer's official physical seal.
So what happens if someone grabs a pen and scribbles over their boarding pass, trying to change seat 20A to business class? The information is changed, sure, but the security stamp is visibly tampered with and no longer valid. The gate agent will take one look at it, realize it's been forged, and reject you instantly. That is the genius of JSON Web Tokens. They are digitally signed tickets that prove who you are, contain your information openly, and allow servers to trust entirely that the data hasn't been messed with. So I'm leaving you with a final provocative thought to ponder as you build your next app. If your token is just a boarding pass, are you guarding your server's secret key as fiercely as that security officer guards their official seal? If this explainer made JWT crystal clear for you, make sure to hit that subscribe button for more technical breakdowns just like this one. Thanks for hanging out, and we'll catch you in the next explainer.